Imagine, through a window in time, we can directly glimpse the early universe. 130 billion years ago, when galaxies were just forming, and the cosmos was still in its infancy. The James Webb Space Telescope, the most powerful space telescope ever built by humanity, is helping us achieve this incredible feat. Today, let's uncover how it pierces through the fog of time and space, capturing the oldest light in the universe. From Galileo's humble refractor, to Hubble's space-based marvel, each step has reshaped our cosmic perspective. Then, on Christmas Day 2021, humanity launched its most ambitious eye on the cosmos yet, the James Webb Space Telescope, or JWST. It's more than a telescope, it's a triumph of science and engineering, a promise to explore the universe for decades to come. JWST is often called Hubble's successor. But it's not just an upgrade, it's a completely different kind of instrument. Hubble mainly observes visible and ultraviolet light, while JWST focuses on infrared wavelengths. This allows JWST to pierce through cosmic dust clouds, and see farther back in time, to places and eras Hubble can't reach. JWST's scientific goals span, from finding the universe's very first galaxies, to analyzing exoplanet atmospheres, to exploring the origins of life itself. It not only continues Hubble's legacy, it opens entirely new frontiers in astronomy. NASA, ESA, and CSA have set 4 core missions for JWST. First, to search for the first stars and galaxies that formed after the Big Bang. Using infrared light, JWST can look back just 100 to 200 million years after the Big Bang, capturing the faint glow of the earliest cosmic objects. Second, to study how galaxies form and evolve. It reveals how chaotic clouds of gas shaped the structured galaxies we see today. Third, to observe the birth of stars and planetary systems. Infrared light can pierce the dusty cocoons where stars are born, allowing us to watch stars and planets come to life. Fourth, to search for planets capable of supporting life. By analyzing exoplanet atmospheres, JWST looks for chemical signs of habitability. The idea for JWST dates back to the early 1990s, just after Hubble was launched. Scientists dreamed of a telescope far more powerful than Hubble, especially in the infrared spectrum. But the journey was long and filled with challenges. Originally planned for launch in 2007, technical difficulties caused many delays. Costs grew from $1 billion to nearly $10 billion. Over 1,000 engineers and scientists from 14 countries worked together for more than 20 years. Finally, on December 25, 2021, JWST launched aboard an ESA Ariane 5 rocket from Kourou, French Guiana. NASA calls JWST the most complex space science observatory ever built, and that's no exaggeration. Some highlights include a 6.5-meter primary mirror, made of 18 gold-coated beryllium hexagons, folded to fit inside the rocket. A 5-layer sun shield, about the size of a tennis court, blocking sunlight and heat, equivalent to an SPF 1 million sunscreen. Its orbit around the second Lagrange point, or L2, 1.5 million kilometers from Earth, provides a stable, cold environment. Infrared detectors operate at -233 degrees Celsius, kept cold with active and passive cooling systems. Webb is not an ordinary telescope. It is arguably the most complex space device ever built by humanity. Its body can be roughly divided into several parts. First, the primary mirror, a 6.5-meter diameter mirror, composed of 18 hexagonal segments. Each segment is made from beryllium and coated with a thin layer of gold. Even more astonishing, these segments align with nanometer precision. This mirror is responsible for capturing faint light from the depths of the universe. Next is the secondary mirror, held by a tripod structure, acting like a relay station, directing the light collected by the primary mirror to the scientific instruments behind it. Then comes the instrument module, which houses 4 powerful tools. An RCam, a deep space imaging powerhouse able to capture the faintest light from the most distant galaxies. NRSpec, which can analyze the spectra of hundreds of celestial objects simultaneously, helping us understand their chemical composition and their motions. MIRI, dedicated to studying extremely cold objects and the atmospheres of exoplanets. And FGS/NIRIS, one specializes in precise target acquisition, the other excels at observing planetary transits, providing key data in the search for habitable planets. Then there is the special sun shield, made of 5 ultra-thin layers of Kapton film. This acts as the telescope's cooling shield. When fully deployed, it is about the size of a tennis court, yet it blocks 99.999% of the sun's heat, keeping the telescope near absolute zero temperatures. Finally, the spacecraft bus. Like Webb's heart and nervous system, responsible for supplying power, maintaining communication, and controlling the telescope's orientation. Across the entire telescope, there are over 350 deployment mechanisms. If even one fails, the mission could be lost. What's more critical? Webb operates 1.5 million kilometers away in space, where no astronaut can repair it. So, from launch to deployment, there is only one chance. Everything must be flawless. Since beginning operations in 2022, JWST has delivered stunning results. It observed galaxies form just 325 million years after the Big Bang, pushing back the earliest galaxy record by 100 million years. It made the first precise detection of water vapor in the atmosphere of WASP 96b. Captured high-resolution images of stellar nurseries, revealing intricate star-forming processes. Using gravitational lensing by galaxy clusters, detected extremely faint and distant galaxies, providing clues about dark matter. JWST opens an unprecedented window into the early universe. It tests and refines cosmological models, while providing key data in the search for extraterrestrial life. It helps us understand how galaxies formed and evolved, stellar life cycles, and which exoplanets might be habitable. JWST will be a cornerstone of astronomy for decades to come. Beyond science, JWST represents human collaboration and creativity. Thousands of people worldwide came together to build this marvel. Each image reminds us how small yet curious we are in the vast cosmos. It inspires wonder, uniting us in the quest to understand our place in the universe. With a projected lifetime of 20+ years, JWST may detect galaxies earlier than currently known, precisely assess exoplanet habitability, shed light on the mysteries of dark matter and dark energy, collaborate with future observatories, pushing astronomy into a new golden age. The James Webb Space Telescope is more than just Hubble's successor. It's a giant leap forward in humanity's ability to explore the universe. Its legacy will expand our cosmic understanding for decades, and inspire generations of scientists, engineers, and dreamers. JWST is truly humanity's pinnacle eye on the cosmos, opening a new chapter in our eternal quest to know the stars.